Integers and floating numbers. So integers. So this is just to give you an understanding of numbers, because I know it's fairly elementary, but you may hear the term integers, you may hear the term floating numbers, particularly you might hear it if you're using computers. Floating numbers are more commonly known as decimal numbers. So, but in the computing world, and particularly software development world, you'll often hear, specifically if you're using C++, you'll declare a number as a float or as an integer. And there's also double, but we'll not go into that in this video. But there's floating integers. So integers are whole numbers, and what does that mean really? Well, if you think of a whole number is something that has to be whole. So it's like if you have screws, you generally have like 40 screws or 44 screws. You don't have 44 and a half screws or 44 and a third screws or 44 and an eighth screw. You generally have 44 screws. Like when people talk about 44 screws, or else you have 44 screws, or else you have 45 screws. So that's, if you think about it, it's something that has to be a whole component. It's like people as well. If you count people, you say how many people is in that building, or how many people is over. As you say, there's 4 people or 3 people. You don't say there's 3 and a third people. Like, it doesn't make sense. But float numbers are different. They're decimal numbers. So decimal numbers can be, if you think of a quantity like water or something of that effect, or a weight. If you're measuring a weight, you generally can have, like, if you say something's filled with a litre and a half of water or a litre and a half of milk, and the same with weight. Somebody can weigh like sort of 14 stone and a half, or 180 pounds and half a pound, or something to that effect. So that's it. So the other one is negative numbers, which I'm just introducing it, but I won't be talking about it in this video. I'll be doing a separate video on that. But negative numbers are obviously numbers less than 0, so it's just -1, -2, and they can either be integer or decimal numbers. So the negative numbers have a specific arithmetic that you need to use, where floating numbers and integers don't. So floating numbers are just added, subtracted, divided, multiplied, whatever way, in the same way as it's not really a big difference. It's just they both are sort of just the standard arithmetic that you probably already know, you've learned in school or whatever. So to describe, so fractions are the other thing. Some people get confused with fractions and decimals. So that the two there gives you an example. So half is 0.5 and a quarter is 0.25. So all the fraction is really just saying a half is obviously 1 divided by 5, and a quarter, 1.25 is just 1 divided by 4. So those decimal numbers, if you don't get confused with the decimal point, if you think of those as like, if you multiply the fraction by, and you have 100 divided by 2, then you're going to get 50. And then if you have 100 divided by 4, you're going to get 25. And then you just so you're just saying 100 is really, what 100 is 100 is 1.00. So if you think about it that way, don't get confused with decimal. Decimal just really is telling you that it's a number less than 1. And in the later slide, I'll talk about scientific notation, and that might help you understand how you can move the decimal point. If you don't get confused with the decimal point, you can actually, just divide it and multiply it, and whatever, like the way you would do with a normal number that's, like a number greater than 1. So these are other sort of, so 3 divided by 4. So if you think of that as 3 divided by 4 is, if you think of that as, I think now, yeah, 3. Well, what you're saying there is you've divided 100 by 4, and then you multiply by 3, which is a bit confusing, But that's what that's saying. So if you think of it as 100, then and you've divided 100 by 4, you end up with 25. But then if you multiply by 3, you'll end up with 75. And it's the same with the other ones, like the thirds. So that's like, if you divide 100 by 3, you'll end up with 33 and a third. And to be honest, a third is one of those numbers that you can, you just add each. You can have a never-ending set of 3s. Or it's like, I think I've described this in other videos. So and the same with 2/3. There's one of those numbers. It's a bit of a, it's not really complete. It can just go on forever, like as such. So it just depends. You include as many significant figures as you want. Like, so in this case, I've included 4, but you can have up to 10. It just depends on how accurate you want to be. In most cases, for most things, and especially if you're just doing sort of, you're building stuff, or you're doing maths for sort of like your you're building something, you're trying to work out a size or something, 2 significant figures would be enough, maybe 3. It depends on your measurement instrument, what you're using. If you're using a router, like, you probably would just, you may need, you just maybe 0.3, 1 significant figure might do. And so that, the last one's then sort of similar thing. So 100 is like, that's 1 divided by 100. So if you think of it, if it was 100, if it was, if you think of that as like, if you multiply the top by 100 and multiply the top and bottom by 100, it's 100 divided by 10,000. So you're going to end up with 1, like, in that case, like. So it's, if you don't get confused with the decimal point, I'm maybe not explaining as well as I'd like to explain this, but the decimal point is just showing you that it's a number less than 1. But the process is that even if you particularly, I'll show you the scientific number and you can move the decimal point forward, and that might help you if you struggle with decimal points in particular. So that's what I was saying there. It's a good example. It's more accurate to say 1/3 than it is to say the decimal place, because there I was explaining the significant figure. So like, you can express a third in terms of significant figures depending on how accurate you want. Like, so you can express it 3 ways there, or as many ways as you want. So for 1 significant it would be 0.3, for 2 it would be 0.33, and for 3 significant figures it's 0.333. Whether something a half is going to be 0.5, there's only one way to explain that. 0.5 is as accurate as 1/2, and but with a third it's not. So depends what you're doing, like. But if you're building something like with a router or something, unless you're doing something really high tech, like, probably 0.3 would do you for most cases, like. Yeah, 0.3 would probably do you, like, if you're building, like, and you're working on something in centimeters or millimeters. If you're working in millimeters, well, you probably won't need to use decimal places, but if you're working in centimeters, you may need to. So you're saying 10 centimeters, so 3, no, it's 0.3 is 3 millimeters then. So because there's 10 millimeters in a centimeter, so you're saying like 3 millimeters would be 0.3 centimeters, that sort of thing, like. So what's with a fraction? I said is a self-explanatory thing there, so you can see, like, and this is what I was explaining to you, like, if you see the way the decimal place is moving. So if you divide 1 by 2, you get 0.5. But at the same time, when you think about it, if it's 10, because I think it might confuse some people if you say 1 divided by 2, because where's the 5 come from? But if you think of it as 10 divided by 2 gives you 5, and 100 divided by 2 gives you 50, and then you've got this scientific notation. So these terms can be confusing. Numerator and denominator. And numerator is just the top line, denominator is the bottom line. And people talk about, and it confused me when I was younger, particularly when I was younger. This confused me, denominators and denominators. But if you remember, one's the top line and one's the bottom line. I think numerator, if you at least remember numerator is the top line, then you can remember the denominator is the bottom line. Because numerator is the number as you multiply it by, like, in most cases, like. So if you think of it in that terms, because, like, if you think about it, a half is simply like 1/2, simply. The next one, 10/2, is simply 1/2 multiplied by 10. It's the same thing, and it's the same as 1/2 multiplied by 100. They all equate to 1 now. So I hope that sort of explains it. And especially if you look at the scientific notations, what that's sort of multiplied by 10 to the 1, multiplied by 10 to the. If I haven't done a video, but if you look at the website, there's a blog article on indices, and it'll explain what those small numbers mean. Which I'm going to probably do a feature video on indices as well, which explain indices. So those are just sort of what that means is 10 multiplied by, like, 10 multiplied by 0 is a wee bit of a confusing one because it goes to 1, like, so it's a wee bit of an odd one out. But 10 multiplied by 1, 10 to the power 1 is just 10, and 10 to the power 2 is what it's saying is 10 multiplied by itself. So if it's 10 by the power 3, then it'll be 10 multiplied by 10 multiplied by 10, sort of like that. But I'll cover that in a future video. But if you watch the future video and then come back to this one, then it would maybe become a bit more clearer. And so this is going the other way. So when you talk about -1, then the decimal place moves the opposite direction. So as you can see there, that's 3 ways of saying it. So, let me see, sorry. Yeah, there's 3 ways of saying it there. Either, it's 3 ways of describing half just using scientific notation, and you can see the decimal point moves there. So, well, it moves one of them, it moves sort of, it's before the 5 when you're saying it 10 multiplied by 10 to 0, but then it moves past the 5 and then it moves to the next 0, when it's 50. But it's just showing you that's where they get the term floating from, and that's why sometimes decimal points are called floating numbers. Decimal numbers are called floating numbers. So scientific, as I said, scientific notation makes use of indices. So it's just a more complex way of displaying numbers, because particularly for these small numbers, yes, you don't really need it. But if you're getting in a number where it's like 0.0005, like for certain things, probably if you're building stuff and doing things like that, it doesn't really, you don't really need to worry about it. But particularly if you're doing computer programs and you're working with big numbers, you can end up with a number that's 0.005 or something like that there. So it's handy then just to sort of just make it 0.5 and say 10 to the power of 10 or something, or whatever, how many decimal places you have there, or significant figures. So that's what scientific is. It makes it more complicated, it makes it more complex, a number. And it's the same if it's like 5 million, then you can sort of say it's 5 by 10 to the 6, something like that. So it's just a good way of compacting numbers down. And it's maybe something like, I'd refer to this, maybe something, if you see some of my later videos when I maybe go into something more complicated and I explain it again, it's good to go back to this video and then maybe it's clearer, and we'll come back. And even if you check out the blog article that I already wrote on this sort of integers and floating numbers and negative numbers. So what like I said, is it's based on an earlier sort of blog posted it on the website. And maybe it was some sort of help, and maybe it'll at least let you'll be able to read the video and find out, help you with the video. So it's just so there'll be a future video on negative numbers. That's the next video I'm going to do, and it's just the usual thing, like, I've mentioned this before. So the topic's all centered around building really helicopters, planes, boats, that type of thing, and using models to, looking at how to use models to help you build things. So if you comment on, depending on the videos what you watch, if you comment on the topic you think you're most interested in any way there's any kind of help improve the videos or make them more interesting. So that's the blog articles there. But if you look at the first blog article, you'll find the reference to the second one. And obviously that's the Moz textbook, which will go into more detail if you really want to go to that sort of level of Moz detail. Okay, thank you for watching then.